quantum photonics is it's a big thing in Bristol and has been for a while, and obviously with the with the surge of AI as a relevant technology, the convergence of those two is obviously a very exciting space to be.
There are many opportunities in terms of us within Bay where we've been involved in quantum key distribution. And how do you make the telecommunications system, the photonic system, more robust in terms of security? We see this as a major opportunity for collaboration and taking PICs and quantum dot emitters, for example, and integrating them within, say, a single package. So you have a package which is able to do the photonic processing, but also the quantum processing in terms of ensuring the security and robustness of the system.
Yeah, sure. So kind of already we're starting to see solutions emerge in PICs where, especially silicon photonics PICs, reducing the energy consumption, reducing the heat dissipation. So straight away there's an impact factor for saving energy when doing a simple search on AI.
I'll start with quantum. Obviously there are a number of companies working in QKD systems where you're putting system down onto the size of a chip, essentially. And that has real benefits in the size, weight and power and cost. So essentially miniaturizing things makes it much better. And the power aspect is just so important, especially when you start going into AI. You know, the demand for data at the moment is absolutely incredible, and it's only getting more. So the ChatGPT models and things like this, the actual demand for data is incredible, and that is really something that's unsustainable with today's technology. So new things like new electro-optic materials are really important, and the way we integrate those with chips is very important. So heterogeneous integration with PICs I expect to be a big topic today.
Well, it's very difficult to get one organization to do everything from conceiving the problem all the way down to installing the product, right? So I think collaboration and creating like a consortium that can tackle the problems from different angles is crucial. So events like this that allow the community of people interested in these applications are brilliant.
Especially in PIC, because the disparity of the number of products, the disparity between the number of products on the market with PICs inside and the amount of research that goes into them is huge. You know, we need to find a way of helping startup companies develop their technology and get these products out into the market quicker. You know, the main driver for PICs at the moment is datacom. You know, if we didn't have datacom, I think the area of PICs might be struggling a bit more. But there's a whole load of money being ploughed into the area, and we need to piggyback off the success of datacom to get PICs into the market. And there's so much potential to have PIC products, miniaturized products, lower power products on the market. And I think the question about what the catapult can do is give startup companies that opportunity to come into the catapult, to use equipment that they probably can't afford to buy themselves at a low cost, more accessible way of using it. And I know many companies in our corporate membership who have had many projects with you and used your equipment. People like Wave Photonics who are here today.
I see the Catapult Centre very much as a focal point, a hub for innovation and technology, where research establishments, academic, industrial as well, can meet, share ideas, share innovation, develop products, promote what we do here in the UK. UK PLC as a place for innovation, new product design, and we can sell that to the world, basically.